Hi, how are you? Hello, hi everyone. Welcome to the Student the Brand. So this is your Siva sir. Today I'm going to explain light reflection and diffraction. New Cartesian Sine convention, new Cartesian sine convention, all a distance measure from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive along the above the principal axis. Distance are negative below the principal axis. New Cartesian. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance are positive along the incident trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian. New Cartesian sign convention. New Cartesian sign convention. So, hi everyone, welcome to the Student the Brand. This is your Shiva sir. Today topic is light reflection and diffraction. So here, when you are taking, when the light is incidenting on the surface, so here I am considering this the plane surface, light reflection and diffraction, light reflection, reflection and refraction, refraction, light reflection and refraction. So this is I'm taking the plane surface. This is I'm taking the plane surface. So this is the plane surface, plane surface, plane mirror I'm taking, plane mirror. So the light which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. Okay. So this is the incident ray, and this one is the reflected ray, and the line which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. Okay. So incident ray, reflected ray, normal line. So here you can observe these are the point. This is the incident ray. So reflected ray and normal line. Incident ray, reflected ray, and normal line. Incident ray, incident ray, incident ray. So this will be the reflected ray, and this one I am considering the normal incident ray, reflected ray, normal line. Okay, so the undeviated line. So this is the undeviated line. So without any deviation it moves. Okay, deviation in the sense, so if you are taking, it is a rarer medium, denser medium. If the light ray is moving from one medium to another medium, so it changes its path. If it changes its path, then we can consider as a, so it is a deviated line. So, but here I am taking this undeviated, means initial direction of the incident ray. This is the initial direction of the incident ray. Initial direction of the incident ray. So, the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Once again, you can observe here. You can observe. So, incident ray, reflected ray, normal. Incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. So what is incident ray definition? The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The line which is perpendicular to the plane surface, the light ray, actually it is imaginary light ray, imaginary line. So that is the reason we are drawing with a dotted line. So we are drawing with a dotted line because it is not existed. Okay. So incident ray, reflected ray. So whenever light ray incident on it, it will be reflected back. But the line which is perpendicular to the plane surface, that is a normal line. So that is a dotted line. So we are representing with a dotted line because it is not existed. For our understanding of reflection phenomena, for understanding of reflection phenomena, we are imagining that line. That is the reason we are drawing with a dotted line. We are drawing with a dotted line. Incident ray, reflected ray, normal line. Angle between incident ray and normal is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay, so what is the angle of incidence? Angle between incident ray and normal line. So that is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. So the total phenomena, the entire phenomena, the bouncing back of the light from the reflecting surface, the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. Okay. So now, so this is about reflection phenomena. And coming to the here, if you are taking this linear angle, how much? So total angle is 180 degrees. Total angle is 180 degrees, right? Yes. So that is included of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation, because so on the line it is there. So rare and medium in the sense, speed of light is less in the medium, speed of light is more in the medium. That is called rare and medium, dense and medium. Rare and medium is nothing but if you take air and water, so this is the air, and this if you are taking water, so the speed will be less in water compared to air. So compared to these two mediums, speed will be less in the dense and medium, more in the rare and medium. Okay, so that's why we are talking about rarer and denser. Okay, so here you can observe this is including of angle of incidence plus angle of reflection plus angle of deviation. That is equal to 180 degrees. That is equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So coming to one phenomena, that is, so you can take phenomena is, so phenomena if you are considering, so that is very easy only, absolute refractive index and relative refractive index. Absolute refractive index is nothing but C by V. Okay, so relative refractive index is nothing but other than air or vacuum. So in absolute, so compulsory one medium must be air or vacuum. Air or vacuum. Okay. So in absolute compulsory air or vacuum. Water, vacuum. Air or vacuum. Not water, vacuum. So we can take, so air or vacuum must be there. So that with respect to that we are taking another medium, either water or glass. Then we can say that is absolute refractive index. Coming to relative refractive index, so different between water and glass. So like different mediums we can say relative refractive index. Absolute is nothing but compulsory. One medium must be air or vacuum. Okay, I hope it is very clear. So now you can observe here. Now you can observe here, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So coming to loss of reflection. So we will discuss about loss of reflection. Loss of reflection. So what is the loss of reflection? So first one is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Okay. Incident ray, reflected ray, normal line lies on the same plane. So incident ray, reflected ray, normal line lies on the same plane. Okay. So that is the first point. Coming to the second point, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Okay. So these are two laws. Laws of reflection. Okay. So now, if you are taking by applying laws of reflection in this equation, so you can observe now. So we will get it. Angle of incidence plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of deviation equal to 180 degrees. Now, angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. So, if you are taking instead of angle of incidence, if I substitute angle of reflection, then we will get 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So I hope it is very clear. Now you can observe here. So this is about reflection phenomena. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. And coming to incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. And angle of incidence, loss of reflection. Coming to loss of reflection, incident ray, reflected ray, normal lies on the same plane. Angle of incident is equal to angle of reflection. So here a linear angle, if you are taking this angle, that is linear angle 180 degrees. So that is include of angle of incidence plus angle of reflection. Of incidence plus angle of reflection plus angle of deviation. So we can take angle of incidence plus here angle of incidence plus angle of reflection plus angle of deviation equal to 180. So instead of angle of reflection, I'm substituting angle of incidence. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180. Angle of deviation equal to 180 minus 2 angle of reflection. So that we can get it, angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of reflection. So this is about loss of reflection. Okay. So now we will go to the regular reflection and irregular reflection. Regular reflection and irregular reflection. So let's start. So reflection and refraction is different completely. Reflection takes place on a surface. Refraction takes means light ray moves through the surface. So if it is medium means it goes through the medium. So bending of light takes place. Here bouncing back of the light. Bouncing back of the light is known as reflection. So bending of the light at the interference of the two media is called refraction. Okay. So coming to regular reflection and irregular reflection. Regular reflection. Regular reflection. Okay. So regular reflection. So what is a regular reflection? Regular reflection is nothing but, so here I am taking, so this is the surface. So if you like the content, if you like the channel, so do like, share and subscribe to Student the Brand. So like, share and subscribe. So ask your friends to join to the class, listen to the class. There are so many videos are there, so related to physics, CBSE grade 10. Once go and watch. Okay, so all definitions parts are there, so you can check once in the playlist. There are many related to physics 11th 10th 11th 12th grade, so definitions are more like all definitions, so clear definitions are given. Okay, just check once. So here regular reflection, incident ray. So incident ray, so I'm taking like here. So all light rays are parallel to each other. All light rays are parallel to each other. So then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. So incident beam, incident parallel beam, incident parallel beam, parallel beam. So reflected light rays are also parallel to each other. Reflected parallel beam. Okay, so here you can observe generally, so light rays are coming from the from object. Okay, object we can take like a sun, like a bulb, like a candle, anything we can give, anything we can take. So the source which gives the light or the object which gives the light, like that we can take from that point. From that point light rays are coming. Source is nothing but which is giving light, which is giving light. Okay, so here I am taking like an incident beam. Here I am taking the incident beam. So all light rays are parallel to each other. All light rays are parallel to each other, and reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. This type of reflection is called regular reflection. Coming to irregular reflection, irregular reflection, irregular reflection, irregular reflection. So surface is not smooth. Surface is not smooth. It is irregular. Surface is not smooth. Hi everyone, welcome to the class. So if you like the channel, do like, share and subscribe to Student Debate and inform your friends. Ask your friends, share to your friends, ask them to join. So incident light rays are parallel to each other. Incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Even surface is also not smooth. It is irregular surface. Surface also not smooth. It is irregular surface. So it goes in different direction. Okay. So rough surface. Rough surface. So incident light rays. Incident light rays. Reflector light rays. Reflector light rays. So here you can observe incident light rays are parallel to each other, whereas reflector light rays are not parallel to each other. Okay, so here you can observe one thing. So this is incident beam, reflected beam. Here incident light rays are parallel, but reflector light rays are not parallel to each other. Reflector light rays are not parallel to each other. So this type of reflection is called regular reflection. This type of reflection is called irregular reflection. Irregular reflection. So this is about types of reflection. So I hope it is very clear. Once again you can observe. So regular reflection is nothing but, so incident beam is parallel, then reflector light rays are also parallel to each other. Reflector light rays are also parallel to each other. That type of reflection is called regular reflection. So here in irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So that type of reflection is called irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. So regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Yes. So even though if it is irregular reflection, so laws of reflection will be applicable. So that is about regular reflection and irregular reflection. So then we'll go to the next. Plane mirror. So I'm taking the plane mirror here. This is a plane mirror. Okay. So normal I am taking. So these are the light rays. Light rays are coming from the source. So here you can observe. After reflection, those light rays are meeting at one point on the principal axis. Okay. So if you are extending the light rays, if you extend these light rays, these light rays will meet at one point. Okay. So here this is the real image. This is a virtual image. Real image and virtual image. Real image and virtual image. Okay. So real image and virtual image. So now you can observe here. So we are extending these light rays. So this is the real object and this is the virtual image. Okay. So here you can observe one thing. Object and image. So I will explain. Don't worry. So small point. Very simple only. So actually here you can observe this is the real image, virtual object. So I'll explain. Here you can see these are the incident light rays. Incident light rays. 1, 2. Okay, these are the incident light rays. Incident light rays. 1, 2. 1, 2. So those light rays, we are extending these light rays. We are extending these light rays. Extended light rays are meeting at one point. We are extending. So here we are extending. Here also we are extending. Extended light rays are meeting at one point. So their image is forming. Their image is forming. What is that image? Virtual image. Object is real. Object is real. Image is virtual. Virtual image. Real object. Real object. Reflector light rays, real image. This is a virtual object, right? Virtual object. We are extending the incident light rays. Virtual object. Incident light rays, reflector light rays, reflector light rays. I did correct only first. Reflector light rays, virtual image, real object, real image, virtual object. Correct only. Okay, now you can observe here. Now you can observe these are the incident light rays. Incident light rays. So incident light rays are coming from the source. Okay, means object. After reflection, those light rays are meeting at one point. So after reflection, those light rays are meeting at one point. Their image is forming real image. The point of intersection of reflector light rays. The point of intersection of reflector light rays. Reflector light rays directly meeting. Reflector light rays are meeting directly. That's why this is called real image. These are extended incident light rays. Extended incident light rays. Incident light rays are extending. Okay, so that's why this is the virtual object. So if you observe carefully here, reflector light rays are meeting at one point directly, that is real image. So incident light rays are extending, that's why virtual object. Here you can observe directly from the point incident light rays are coming. Okay, so this is incident light ray 1, incident ray 2. So this is a reflected ray 1, reflected ray 2. This is I1, I2, reflected ray R1, R2. So incident ray I1, reflected ray R1, incident ray I2, reflected ray R2. After reflection, those light rays are meeting at one point. Okay, so after reflection, those light rays are meeting at one point. That's why it is a real image. Real image. So incident, we are extending the incident light rays. Extended incident light rays are meeting at one point. That is a virtual object. Whereas here you can observe real incident ray 1, reflected ray 1, incident ray 2, reflected ray 2. Okay, so from this point, incident rays are coming. Okay, so incident rays are coming. That's why this is a real object. So after reflection, we are extending the reflector light rays. That's why virtual image. Here you can see extended light rays gives virtual. Either incident rays if we extended, virtual object. Reflector light rays if you extend, virtual image. Okay. So I hope it is very clear. So you can observe carefully. Once again, check once this one. Check once. So check once carefully, automatically you'll get it. So very easy only. So I hope it is very clear, right? So once again observe here, incident ray 1, incident ray 2, reflected ray 1, reflected ray 2. So incident light rays are coming from the source. After reflection, those light rays are meeting at one point. So we are extending these incident light rays, those are meeting at one point. Here, directly incident light rays are coming from this point. So that's why this is called real object. After reflection, reflector light rays are extending. So those reflector light rays are meeting at one point. That's why that is virtual image. So here you can observe here. Object is real. Object where it is real. Here object is real. What about image? Virtual. So now object is virtual. Where is object virtual? Here is object virtual. What about image? Image is real. That's enough. Simple technique. Okay. So if object is real, image is virtual. If object is virtual, image is real. Clear? So make sure that you are following this one. Okay. So very simple technique, very easy technique. So follow. Definitely you'll get it. Understood? So this is very important. So there is a possibility to ask this type of question in the exam. Okay. So now we'll go to the next one, next concept. So next we'll discuss about the nature of the image formed by the plane mirror. So nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror topic are characteristics of the image formed by the plane mirror. Okay. So same thing. First point is object is real, image is virtual. Object is virtual, image is real. So point number 2. Once again, so this the distance between object to mirror is called object distance. The distance between object to mirror is called object distance, and the distance between mirror to image. So this the mirror and image distance. So once again, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. And so object distance is equal to image distance, and the height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay. So once again check here. If object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Okay. And object distance is equal to image distance. Object distance is equal to image distance. And height of the object or size also we can say. Height of the object is equal to height of the image, or size of the object is equal to size of the image. And it also shows lateral inversion. Sir, what is lateral inversion? Lateral inversion is nothing but, so when you lift your right hand, so if you lift your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. Okay. So the phenomenon of converting of left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. This mirror image is called lateral inversion. So you can see the ambulance word written on the vehicle will be in the mirror image. Okay, so if the if ambulance is coming from back, if you see through the rear view mirror, by bikes or cars, so like, so in the mirror it appears proper ambulance. Okay, because so it is a mirror image. So our right side image appears to be our right side object appears to be left side of the image. Our left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay. So I hope it is very clear. So these are the characteristics of the image formed by the plane mirror. First point is object is real, image is virtual. Object is virtual, image is real. And object distance is equal to image distance. And size of the object is equal to size of the image. And it also shows lateral inversion. And one more thing, the magnification is very important. Magnification is +1. So what is magnification? So the ratio of height of the image by height of the object, that is called magnification. The ratio of height of the image by height of the object is called magnification. So magnification of the plane mirror is +1. So m equal to +1. Okay, so m you are taking +1. So height of the image by height of the object equal to +1. So that is about okay. So now we'll go to the plane mirrors. Plane mirrors completed. Concave mirror, types of mirrors. Concave mirror and convex mirror. So now we will discuss about types of mirrors. So there are two types of mirrors, concave mirror and convex mirror. So concave mirror, okay, generally spherical mirrors. So what exactly spherical mirrors? The mirrors which is in the form of spherical shape. So those are called spherical mirrors. Okay, like spherical in the sense curved shape. The mirrors which are in the shape of curved surface. Those are called spherical mirrors. So spherical mirrors are two types. One is concave mirror, another one is convex mirror. Concave mirror. So the mirror whose reflection takes place inward. Reflection takes place inward, that is called concave mirror. Reflection takes place outward, that is called convex mirror. So concave mirror means reflection takes place inward. Convex mirror means reflection takes place outward. Okay. So now we'll discuss about types of mirrors, and actually here concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Sir, why you are calling concave mirror as a converging mirror? Because whenever light rays are incidenting on it, after reflection, those light rays will be converged and meet at one point. So that's why it is called converging mirror. So why convex mirror is also called diverging mirror? After reflection, those light rays are moving away from the principal axis. Those light rays are moving away from the principal axis. That's why it is called convex mirror. Okay, na? So now we will discuss about ray rules and image formations, everything. We will discuss about concave mirror, spherical mirrors, concave mirror. We'll discuss concave mirror, and convex mirror also. So at a time we will discuss about ray rules and image formations. Coming to concave mirror, so the mirror whose reflection takes place inward. So I'm taking the concave mirror like this. So this is the concave mirror. So incident light rays reflects inward. Okay, na? So like here. So after reflection, those light rays are meeting at one point. So here you can observe after reflection, those light rays are meeting at one point on the principal axis. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror, whereas convex mirror is known as diverging mirror. Convex mirror is also known as diverging mirror. So why convex mirror is known as diverging mirror? So here you can take, so here light rays are incidenting on it. After reflection, those light rays are moving away from it. Okay, so after reflection, light rays are moving away from it. If you are extending these light rays, those light rays will meet at one point. So convex mirror is also known as diverging mirror. Diverging mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. So here you can observe carefully. Okay, so here reflection takes place inward, here reflection takes place outward. So concave mirror, converging mirror, convex mirror, diverging mirror. Right? So I hope it is very clear now. So we'll discuss about ray rules and image formations. So ray rules and image formations we'll discuss. So be ready for it. Ray rules. Concave mirror. So ray rules. And this side we'll draw the convex mirror. Convex mirror. Concave mirror and convex mirror. So now concave mirror, first point. So pole. So before that we'll discuss one point. So that is about terms related to concave mirror. Then I will go with that concave mirror and convex mirror. Actually every time, so you see my videos, many of my videos, only this part I'll start this one, then I'll go to that. So okay, So I am taking actually spherical mirror. Now especially I am taking the concave mirror. So this is a concave mirror I am taking. This is a concave mirror. Okay, so it's a part of the sphere. Part of the sphere. So terms. First we'll discuss about terms related to spherical mirror. Then I'll go to this. So I'll get confusion. So because after this only we have to discuss those points. So better we'll discuss this for our clarity. Terms related to spherical mirror we'll discuss. Terms related to spherical mirror. Terms related to spherical mirror. Spherical mirror. Terms related to spherical mirror. Okay. So now you can observe here. I am taking this concave mirror. This is center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Okay, so this midpoint of the mirror is the pole. So I am taking the concave mirror. The line joining of central curvature and pole is called. The line joining of central curvature and pole is called principal axis. And the distance between central curvature and pole is called radius of curvature. So this distance is called radius of curvature. This distance is called radius of curvature. Point number 1. So central curvature. Point number 2, pole. Point number 3, radius of curvature. Point number 4. So after reflection, all light rays will meet at one point on the principal axis. So after reflection, all light rays will meet at one point on the principal axis called focus. Okay. So after reflection, all light rays are meeting at one point on the principal axis called focus. So focus. So fifth one, the distance between focus to pole. Focus to pole is called focal length. And the sixth one you can see, width of the mirror is called aperture. So this width of the mirror is called aperture. Okay. So aperture concave mirror only. So if you place at light at focus, parallel beam you will get. That's why we will use for headlights. Okay. Concave mirror is suitable for headlights and torch lights. Okay, so center of curvature, pole, radius of curvature, focal length, this is a focus, aperture, and a principal axis. Seventh one is principal axis. I hope it is very clear. So this is about terms related to spherical mirror. Okay, so these are the terms. Now we will discuss about ray rolls and image formations of concave mirror. So ray rolls and image formations of concave mirror. So ray rolls will discuss ray rolls. Okay. Concave mirror ray rolls and convex mirror ray rolls. Concave mirror, and here a convex mirror. First point. So this is the pole, focus, center of curvature, pole, focus and center of curvature. So after reflection, first ray, so light ray is coming from infinity. After reflection passes through focus. Second one, so pole, focus, center of curvature, light ray is passing through focus. Light ray is passing through focus. After reflection moves towards infinity. And coming to third one, so pole, focus, light ray is passing through center of curvature, so it retraces its original path, means moves in the same path. And coming to the next one, so pole, focus, center of curvature, light ray is incidenting at the pole, it reflects back. Okay, so these are the concave mirror ray rules. Okay, so next one, convex mirror. So pole, focus, center of curvature, pole, focus and center of curvature. So light rays coming from infinity after reflection passes through focus. Second one, light rays passing through focus. So pole, focus, center of curvature, light rays passing through focus. So after reflection it moves. Coming to third one, can observe here. Third one. So pole, focus, center of curvature, light rays passing through center of curvature, it retraces. So it retraces. Okay. Next one. Fourth one. So pole, focus, center of curvature, pole, focus and center of curvature. Light ray is incidenting at the pole, it reflects back. Okay. So I hope it is very clear. Just check once. So now you can observe. So light ray is here in this case. In this case you can see light ray is coming from infinity after reflection. Light ray is passing through focus. Here you can observe light ray is passing through focus after reflection moving towards infinity. Here passing through center of curvature. Here light ray is incidenting at the pole. And coming to the convex mirror, light rays coming from infinity after reflection passes through focus. Here light rays incidenting passing through focus after reflection it moves towards infinity. And coming to here, light rays incidenting so on the curvature after reflection moves again back, it passes through center of curvature. And coming to here, light ray is incidenting at the pole, it reflects back. So here these are concave mirror and convex mirror. So ray rules and image formations. Ray rules and image formations. Now we will discuss about These are the ray rules. Next we'll discuss about image formations. So be ready for it. Okay. So image formations we'll discuss. So here I am taking light rays. Now image formations of concave mirror. Image formations of concave mirror will discuss. Concave mirror. Concave. Concave mirror. So first one is pole, focus, center of curvature, pole, focus and center of curvature. Object is at infinity, so light rays are coming from infinity. Object is at infinity. Object is at infinity, image is forming at focus, nature of the image is real and inverted, and size of the image is highly diminished. And points, actually diminished image, point size image is forming at focus. And coming to the second one, so pole, focus, center of curvature, pole, focus and center of curvature. Object is placed beyond center of curvature. Object is placed curvature. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this. So after that it passes through focus. So another light ray I am taking like this. It passes through center of curvature. Okay. So the distance between C and F is called, sorry. So the image will form between C and F. The image is forming between C and F. Okay. So object is placed beyond C. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted, and size of the image is so diminished. Highly diminished we can't say, because compared to the object, image size is decreased. So diminished. Diminished. So coming to the third one. So light rays are coming from here, right? So after that it so retrace, moves in the same path. So light rays are coming, after reflection passes through focus. And coming to the third one, here you can observe, so pole, focus, center of curvature, pole and focus, center of curvature. Object is placed at C, image also will form at C. Object is placed at C, image also will form at C. So one light ray I'm taking like this, it passes through. So one more light ray. So here object is placed at C, image also will form at C. So object is placed at C, image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Same size. Okay. So these are the three image formations. So once again check here. You can take a look. So object is placed at infinity. Object is placed at infinity. Image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. Object is placed beyond center of curvature. Image is forming between C and F. Nature of the image is real and inverted and diminished. Here object is placed at C. Image also will form at C. Nature of the image is real and inverted and same size. Okay, same size of image will form. Right? I hope it is very clear. Now three more image formations are there. We'll discuss. So concave mirror. So pole, focus, and center of curvature. Object is placed between C and F. Object is placed between C and F. One light I am taking like this. It passes through focus. So another light ray is passing through center of curvature. So passing through incidenting at pole. So one light ray is passing through focus. Another light ray incidenting at pole. Then those light rays will meet beyond C. So image will form here. Okay. So here you can take object is at between C and F. Image is forming beyond C. Image is forming beyond C. Nature of the image is real and inverted, and size of the image is enlarged. Enlarged compared to object, image size is increased. So fourth one, coming to fifth one. Fifth one is, so here you can observe fifth one. So pole, focus, center of curvature. Pole, focus, center of curvature. So I am placing at F. One light ray I am taking like that. So it passes through focus. So another light ray incidenting at the pole, it reflects back. And if you are extending these light rays, those light rays will be meeting pole at focus, right? At focus means at infinity. So it will become parallels. Focus, right? Object is at focus. Image is forming at infinity. Nature of the image is real and inverted. And size of the image is highly diminished. Highly diminished or enlarged? Highly enlarged. Highly enlarged. Highly enlarged. Because so image is formed at infinity. Okay, so here. So object is placed at F, image is formed at infinity. Coming to sixth one, this is very very important. So make sure that you are learning this one. Sorry. So pole, focus, center of curvature, pole, focus, center of curvature. So how many light rays? If I place the object, so I'm placing object between F and P. I'm placing the object between F and P. One light ray I'm taking like this. So after that it passes through focus. Another light ray is incidenting at the pole. Actually, we can take through center of curvature also. We can take through center of curvature also. We can take. So after reflection, so we can here, if you are extending like this, so image will form here. Okay. Object is placed between F and P. Object is placed between F and P. Image is forming behind the mirror. Behind the mirror. Okay, nature of the image is virtual. Nature of the image. Virtual, erect, and enlarged. Virtual, erect, and enlarged. Okay, now check once here. Virtual, erect, and enlarged. So if you like the content, if you like the channel, if you like my explanation, do like, share, and subscribe to Student D Brand. So this is your Shiva sir. So once again, so check here. Object is placed. Object is placed between C and F. Image is forming beyond center of curvature. Image beyond center curvature. Nature of the image is real and inverted. Size of the image is enlarged. And the next one. So fifth one, object is placed at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Compare next one, object is placed between F and P. Object is placed between F and P. Image is forming behind the mirror. Nature of the image is real and inverted, and size of the image is enlarged. So object is placed between F and P. Image is formed behind the mirror. Nature of the image is virtual, erect, and enlarged. So this is very important. So this case is very important. Make sure that you are preparing, you are learning, you are practicing. Definitely 3 marks question will come in the exam. 3 marks. 3 marks question will come in exam. This is very important. And okay, here this one also very important. So can you tell the difference between this one and this one? Here object is image is real, inverted, and enlarged. Here image is virtual, erect, and enlarged. So in these two cases only you will get image is enlarged. Here you will get real, here you will get virtual. So two cases are very important. So they may ask the difference. In concave mirror, you will get a real, inverted, and enlarged, virtual, erect, and enlarged. So draw the image formations and give the difference between them. And what is the position of the object, what is the position of the image. And so nature anyway they mentioned. So real, inverted, and enlarged. Real, inverted, and enlarged size. So real, inverted in fourth case, virtual, erect in last case, sixth case. Virtual, erect and enlarged. Real, inverted, and enlarged. So these two cases are very important. Make sure that you are practicing these two diagrams. So compulsory you must practice these two diagrams. Okay. So we'll take small break. We'll come back. Okay, now, so I hope you like this explanation, you like the concepts. So do like, share, and subscribe to Student the Brand. Do like, share, and subscribe my channel, and share with friends, refer to your friends, ask your friends to join. So next, magnification, size of the image by size of the object, that is called magnification. Okay, so sign conventions are very important. Sign conventions are there. So image object is placed in front of the mirror, means all distance are taken along the incident rays positive, opposite to incident rays negative, above the principal axis positive, below the principal axis negative. This is about sign conventions. And magnification is height of the image by height of the object, that is about magnification. Clear? That's enough. That is about magnifications. So we will discuss few more related to lens. So lens we will discuss. I will let you know in the further class. So thank you so much for joining and attending and listening my class. So if you like the content, if you like the explanation, if you like this videos, just check once. There are so many videos are there related to physics, especially light reflection, diffraction concepts, and human in colorful world, magnetic effects of electric current, and electricity problems are there. There are many videos are there. So just go and check. If you like the channel, if you like the content, please do like, share, and subscribe to Student the Brand. Thank you so much. This is your Sir signing off.